Okay, so let us start CSEC Physics Paper 1 for June 2016. I'll try my best to explain as I go along, but I'll be mostly giving the answer to the questions. But if I see something that is not so intuitive or a little complex, I will explain it. So number one, which of the following pair of points are in phase? The answer is C. It would be S and V because both S and V are traveling in the same direction along the wave that is propagating in this direction. So the wave is actually going in that direction to the right. And out of all these options right here, only S and V are going in the same direction. Let's take Y and P, Y and W for an example. Y would be going down while W is going up. And all the other options are the same cases except C. So C is the answer right there. Let's move to given that force equal mass times acceleration, the unit of force would be written as, so we know the unit of mass is, SI unit of mass is, yes, kilogram. And the SI unit of acceleration, excuse my penmanship, is meters per second squared. So that should be an S to the negative 2. So the answer for this question would be right here, D. Number 3. Number 3 asks for the SI unit for temperature. The answer is C, Kelvin. Number 4. In carrying out an experiment to locate a real image, so it wants us to locate the real image using a converging lens. The object can be placed at between the focal point and lens? No. At the focal point? No. Between the focal point and the point at twice the focal? Yes. If you should place an image at a point less than the focal point, you would get a virtual image and not a real image. You have to place it beyond the focal point. It has to be beyond the focal point. Moving on. So the answer here is D. Number 5. The moment of a force may be defined as, the answer is C. The product of the force and the perpendicular distance from the force to the turning point. Here's the definition. You may read that and remember it. Number 6. Speed up a bit. What should be the magnitude and direction of a third force which will cause the object to remain stationary? Why would the object remain stationary? We have two forces acting to the right, going to the right, two forces, so X and Y. We can use this blue line to represent X and Y combined. The only way this would remain stationary is if we have another force over here acting to the left. So immediately we can zoom in on these two options. So the force has to be acting to the left to cancel out the force on the right and the left-hand side acting to the right. But this force also needs to be equal to the two forces acting to the right. So the answer would be B, a force that is the sum of X and Y. That would let the box remains stationary. It would be a deadlock. Moving on to item 7. It reads, when a force F is applied to a spring of original length L, the new length becomes L plus X. What would be the new length of a spring if a force of F over 2 was applied instead? So F is equal to negative K X. Force is directly proportional to the extension on the string, which is X. So if we should divide the force by 2, then the extension would also be divided by 2. So the new length would have to be X over 2 plus L. And which option is that? It's D. So the answer here is D. Let's move on to item 8. Which of the following equations must be true in order for the ring to remain stationary? So this is very similar to item 6. For this right here, to remain stationary at R, all the forces have to sum up to 0. So when you sum the forces, you should get 0. So it seems like L and M can be equal to N. So they can add up to 0, or opposing forces must be equal. So the reason why the answer would be D is because N, the resultant force of L plus M would equal to N. So N in itself is actually L plus M. So the two forces, L plus M, are equal to this one force N right here. And L plus M would be going in that direction. The resultant force of both of them would be in this direction, and N would be acting directly opposite to that in this direction. So D would be the case. Two forces, 8 newtons and 10 newtons, cannot give a resultant of, and this is easy, don't worry, it's very easy. The answer would be 1 newton. Because the least amount of resultant that you can get is actually when the forces are opposing each other. And let us look at the least resultant that you can get. This would be 2 newtons. 10 newtons minus 8 newtons. This is the minimum. This is the absolute minimum force that you can get from these two interacting. And this is when they're opposed to each other, completely opposite. So you can get 1 newton from those two interacting. Number 10. Number 10. Number 10. So we should analyze this graph and answer the question. So from the graph, it can be deduced or deducted that the runner is B, moving at a steady speed, because we see that there is a constant change in displacement with respect to time. So he must be moving at a constant speed. Number 11, a block is allowed to fall freely towards the ground. As it falls, its gravitational potential energy, we know this. So at maximum height, potential energy is maximum. But as an object begins to fall, its potential energy, yes, begins to decrease, but its kinetic energy starts to increase. So the answer would be decrease. And the answer is D. It is converted to kinetic energy. So we see a decrease in potential energy resulting in an increase in kinetic energy. So that's that for that question. Let me get this off screen. Number 12. Two smooth spheres, A and B, collide head-on. Which of the following statement is or are true? The answer is B only. The momentum of B is this. B only, B only, B. This is the B right here. Let me separate this B. So it's 3 only. The total momentum of A and B is the same after the collision as it was before. Basically, they are saying that total momentum before collision is equal to the total momentum after the collision. Number 13, and we're going good so far. 13, the vectors at point O, origin if you want, and are directly perpendicular to each other. Which of the following pairs represent both the magnitude and direction of their resultant? How are we going to do this? Let us use the head to tail diagram. So we're going to move one of these. Let's move OA. And we're going to put OA right here. Let me get the arrow. We're going to put OA right here. So this is now OA. And we're going to connect OA to B using a resultant vector. So do you remember how to do this? You're going to connect this tail to the head of C. So connecting the tail of OB to the head of OA. And you get a resultant vector in the direction OC. So we know what we're looking for now. So let's go down here. Let us zoom in on OC first. So we have two OCs. One OC right here and another OC right here. And we see the difference in both of them is the magnitude. What's the formula for finding resultant vectors using the triangular method? Waiting. Okay. Yes. Is that same Pythagoras theorem, which says that r squared equal a squared plus b squared. But we want to find r, which is a resultant. So a squared plus b squared would have to be square rooted to find the magnitude. So the answer is D and not A. So although A has the correct direction, it does not have the correct magnitude because we want R and not R squared. Yes, if I'm going too slow for you, man, you don't need this. The height of a liquid in a vessel is h and its density rho. If the atmospheric pressure is x and the acceleration due to gravity is g, what is the pressure on the base of the vessel? So first of all, we're finding pressure. We're finding pressure, and we see we already have a pressure in the equation. So let's put that pressure over here. Put that pressure x over here. So this is ATM. So this is the atmospheric pressure. But we want to find the pressure of the liquid, and we know that is equal to rho GH. So density times acceleration due to gravity, that's a multiplication sign there, times height of the liquid in the column. And what we'll do with this equation now is add rho GH, which is the pressure due to the fluid alone on the base of the container, to x. So we should have something like x. So we should have something like x plus rho g h. Here it is right here. So we're basically adding two pressures. So adding the atmospheric pressure to the pressure in the container, of the container on the base. And that's simply it. It's nothing hard. So number 15, specific latent heat of vaporization of water is that number right there. When 1 kilogram of water is converted into steam, what would it do? Would it absorb or give off energy? For it to be converted from liquid to steam to gas, it would have to absorb energy. But how much would it absorb? So let's go back to this word right here, specific latent heat. Specific latent heat of vaporization. So we'll be talking about 1 kilogram of water. So the amount of heat it takes to turn 1 kilogram of water into vapor would be this number right here. But we're not working with 1 kilogram. We're actually working with 0.01 kilogram. Therefore, we would have to divide this number right here by 10, multiply it rather by 10 to the negative 2, or divide it by 100. That would leave us with this value. Realize it's 10 to the 4 instead of 10 to the 8. Moving on, we're at 60 now. A body weighs 60 newtons on Earth. When taken to the moon, the body weighs 10 newtons. Which of the following would be the main reason for this fact? Let's look at it. So the Earth rotates around the moon. No, the Earth has a larger mass than the moon. That sounds credible. Yeah, that sounds true. It's true. On the moon, there is no atmosphere. Let's go with B, which is 2 only. That's the answer. Because the mass is different, the gravitational pull of the moon would be different. And we know it's less, so the body is going to weigh much less. Moving on to 17. Let's go down there and see what's happening. 17 says, what temperature is indicated by the clinical thermometer? Let's zoom in on that. Zoom in a little more, a little more, a little more. Let's go down. No. So let's look at it. Let's zoom in a little more. I still can't see. I don't wear glasses. Yes, this should be good for you. So we have 35 right here. You can see a big stroke right here. And let's go in the middle. So the middle right here would be 36. So between 35 and 36, we have 10 smaller strokes. And the meniscus of this thermometer would be right here. So 35, and you go 35.1, 35.2, 3, 4, 5, 6, 7. It's my cursor. 8, 9, 36. So let's jump the gun a bit now. So this would be 37.5. This would be 38. We'd have 38.5 right here. Let's write that. 38 point. That's not 39. That's 38. Yeah, we're working with that. 38.5. And then 38.6, 38.7, 38.8. Hopefully that's it. Right here is 0.8. Let me just put 0.8. Yeah, so it's 38.8. Let's hope that's one of the options. I believe it is. It must be. Yes, it is. So the answer is D. The answer is D. On now. 280. So 18. Under which condition may we apply the following combined gas formula? So this is the combined gas formula, and the answer is A. The mass of the gas must be constant. Okay, let's go on to 90. Who was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy? That would be Joule. Joule. 20. Which of the following methods is the most suitable means of heating a brass bulb in order to determine its speed by the method of mixtures? The answer to this would have to be C, because that's the only one that incorporates using a mixture of water bath, and that is actually the method used to measure specific heat capacity of certain solids, certain materials. Moving on to 21. The energy required to change the state of a substance is determined by EH. If the mass of the substance was doubled, the value of EH will be double too. And you can go back to the example that we did, but in the extension of the spring, it's the same principle. Moving on to 22 now. Which of the following statements is false? A. Evaporation occurs at room temperature only. No, my friend. That's like one of the first things you are taught. That blows our mind. Evaporation happens at almost any temperature. Let's go on ahead to 23. Oh, it's down here. Most refrigerators are painted white because white is a good reflector of thermal radiation. B. Yeah, not that hard. Moving on to 24. Which of the following diagrams best illustrates convection current in a liquid? A. And if you don't believe me, you can go in your kitchen and actually watch those bubbles go up and the water in return plunging down in the pot. Just don't hold your head over the pot. Let's move on. 25. Where is 25? Okay. The heat from a nearby fire reaches just mainly by. So realize they have important mainly. That is because it can reach us by conduction, convection, and radiation. However, radiation would be the answer because it is where the greatest amount of heat is transferred to us. Convection, a little. Conduction, how would the conduction come into play? Unless you're like holding on to a metal or something that's in the fire. Convection would be there, it would be transferred by convection, but it would be dispersed over in the atmosphere. So the answer would be D. Radiation would be the main way that you feel it. 26. Which of the following is the poorest conductor of thermal energy? So we have these metals right here, and then we have air. And here's the odd one out, and it is also a poor conductor of heat. Thermal energy, if you were to compare it with these nice metals right here. So the answer is the one that you see circled, squared, box. 27. Which of the following descriptions refer to both a good absorber and a good emitter of thermal energy? Let's waste no time in saying it is this one down here that is flat. The surface is exposed. It is flat and it is painted black. Black is a good absorber and a good emitter of thermal energy. Remember that. 8. Which of the following diagrams best represents the wave generated in a ripple tank by a small spherical dipper vibrating at a constant frequency? I believe most persons would exclude B and D and have a little problem with A and C. But unfair. The answer right here would have to be C. A is more of a cartoonish perspective, but in reality, You would have the waves that are closer to the object being even closer together. And as you move further away, distance between the waves become greater. So the answer is C. #29. From the information given, the frequency is, and you can get the frequency from this. So frequency is a function of time. So if they give you nothing right here to actually calculate the frequency using some information about the time, there's no way you can get it. And we know frequency is 1 over the time period, which is basically the amount of waves. Frequency is the amount of waves you can get in 1 second. Where here do you see a second, a minute, or hour? Here, nowhere. So we would say D, unknown. Good. Brilliant. Let's go. The range of frequencies detectable by the normal human ear is, and I'll just give you this one, it's B, 20 hertz to 31. The amplitude of the wave is, so let us look at it. We have this arrow right here, and the arrow is 8 cm, and it seems like this horizontal line would cut the arrow right in two. Therefore, at this end, from the blue line here, would have to be 4 cm, and then you'd have another 4 cm down here. So the answer for the amplitude is 4 cm. On 32. Ah, this one looks nice. An object O is viewed in a plane mirror PQ. Which of the following diagrams correctly shows the formation of the image? First of all, let us look for the image that has both depth and the arrows are arranged correctly. So let's look at A. So A shows the rays from the object, right? And then it shows those rays actually bouncing back from the mirror within the human eye. But the human perceives, as you can see by these broken lines, the human perceives that it is actually coming from somewhere in the mirror. We also see that the depth is reflected. So the mirror reflects the image of the object with the same depth. Let's look at C going across. Look at C. So C actually shows that the real rays are coming from the image, which is not true. That's not true. Now B shows the rays are actually coming from the human eye. So basically what this is trying to say is that the human eye is creating the object, creating the object, which is not true. This would mean that if you don't see something, it's not there. Actually, it is there even if you don't see it. D, on the other hand, it has the arrows arranged correctly, but there is a subtle difference. If you realize the depth right here is actually different from the object. So from the object to the mirror, the depth from the object to the mirror, the distance is different than the apparent image to the mirror. And so we'd have to go with A, which maintains both the depth and the arrows are arranged in the same direction, in the correct direction. Move on to 32. 33. 33 asks us to determine the refractive index of the glass. And we know that refractive index equals sine I over R. So sine incident angle over refracted angle. And if you look right here, this would be I and this would be R. So we're looking for sine M over sine N. Oh, B. That's the answer. We're not looking at anything else. B is the answer and we're good with that. Let me clear all these drawings. IM represents the image formed. The lens is placed at the 50 centimeter mark of the scale, and that scale is marked every 10 cm. So the focal length of the lens is, the focal length would be where the ray of light cuts the principal axis. The principal axis is actually this scale right here. So this would have to be the focal length. I'm circling it. So right in the center right here, the focal length. And since the lens is placed at the 50 mark, and the focal length looks like it's in between 60 and 70. We could say it's 65. So from 50 to 65, that's 15 cm. So the focal length is where that ray of light cuts the principal axis. And that is actually 15 centimeters away from the lens. A ray of white light enters a transparent glass prism in which the following diagrams is the dispersion of light. In which of the following diagrams is the dispersion of light correctly illustrated? And let us just look for Roy G. Biv. And Roy G. Biv is actually A. The reason why we look for Roy G. Biv is because these lights of the spectrum, the lights of the white light that make up the spectrum, they actually leave the prism at different angles. So some are bent more than others. So we would have red coming out first up at the top, and then we would have violet down here. So it would follow this arrangement: red, orange, yellow, green, blue, indigo, and violet. Yes, so it would be A. The light enters here, starts to be split, and by the time it exits, the rays exit, you have the entire spectrum of the white light being exposed, with being reflected with the least angle. And as you go down the spectrum, you realize that the angle increases. 35, A. Let's continue down to 36. It's right over here. Which diagram best shows the path taken by a ray of light through a rectangular block? It wouldn't be A. It would not be C. And it would not be D. So that means again. It wouldn't be A, no. Certainly wouldn't be B. And it would not be D, it would be C. Reason being, angle upon entrance must be equal to the angle upon exit. So let me just highlight for you. Right here should be equal to right there. But inside the block is where we have the shifting angle, but as it exits with the same angle. All of these have varied entrance angles and exit angles. Seven. Which of the following statements about the wave shown in the diagram is or are true? This would be D. S and T are out of phase. We saw that in an earlier question. The wavelength of the wave is distance PR, so it's one complete oscillation. So from P to S to Q to T to R, that's one oscillation. Let's see why I is not included. I says P, Q, and R are in phase. P, Q, and R. That's not true. P is actually going up, while Q is going down, and then R is going up. So this would be out right here. This one would be going down. Q. Any particle at R would be going up. Any particle at P would be going up also. So P and R would be in phase, but none of them would be in phase with Q. So that is why we would exclude this and this. And then we see where 3 is also true. So we have to include 3 in the answer. So right here we would choose D. Let's move on to 38 now. In which of the following would a change be detected if sounds of different frequencies are played in succession? So here, it's basically talking about constructive and destructive interference. In this case, it is destructive. It is a destructive interference. So they have the same amplitude, right? But they have different frequencies, meaning that they can be out of phase. So are in phase. So the loudness would surely be affected because if they are 180 degrees out of phase, then they would basically cancel out each other and you would not hear any sound. If they are in phase, the sound would be amplified and you would have 2 times the amplitude of the individual wave. So it's loudness that is affected. 39. The magnetic induction occurs when D, an electroscope, is charged. And I really advise you to go and look at the topic induction. This is where you can actually place a charged particle or charged material next to another one and actually induce a charge on that material. 40. Following electromagnetic waves has the shortest wavelength. This would have to be C. Radio waves have the shortest wavelength. And just for a bonus, yes, they have the shortest wavelength. 41. Which of the following diagrams shows a magnetic field between a bar magnet and a piece of iron? So we have a bar magnet and we have an iron. Let's look at it. So the bar magnet should have a magnetic fields, but the iron should have no magnetic field. And we know for a magnetic field for the North Pole, the arrows would point inwards. And for the South Pole, the arrows would point outwards. So A would be the answer. 41. A. What did I say? The answer is C. C is the answer. So actually, the South Pole, the arrows point inwards towards the South Pole. So C would be the answer. Let's move on. Which of the following diagrams best represents the magnetic field around the wire? The answer is D. So you'd have to use Maxwell's right hand grip rule. So use your right hand and you are going to position your thumb in the direction in which the current is flowing. So in our case, the current is actually flowing into the screen. So this X means it's the back of the arrow you're actually seeing. So let me draw that arrow so you can see. So you have an arrow, right? And at the very back here, you'd have something like this. You know those little prongs that they put at the back so you can hold in the bowstring to be pulled back and released? Yes, so that would be the X right here. And therefore, that would mean that the current is actually traveling into our screen. So you have to point your thumb into the screen and then you realize that your four fingers will be pointing down. And as you close your fist, it will be coming up. So your fingers should be pointing down like this, right? These are fingers. With your thumb, and this is a right hand, your thumb pointing towards the screen. And if you realize your fingers would come around like this if you were to clench your fist, and so the answer would be D. It would be going in a clockwise direction, magnetic field, while the current is going inside the screen. 43. X is probably a solenoid. 44. Which of the diagrams above correctly shows the magnetic field created? Let us look at it. And this would have to be A. It will have to be A. Because only A has the correct notation. E has no arrow at all. Number 2 has no arrow at all, right? And I actually shows the magnetic field lines moving from north to south, which is indeed correct. Let us look down at number 3, II. The problem with II is that you have some arrows going inside the solenoid or towards the solenoid while you have some coming out. So you have some conflicting arrows right here. Is either they're going out in this direction and coming around, and going in this direction again. You cannot have some going this direction and others going in the other direction. I hope I explained that correctly. Or hope I explained that quite nicely for you. So the answer will be only. Okay. Alright. Which of the following is more suitable for the core of an electromagnet? The answer is D, soft iron core. Which of the following circuit symbols is a fuse? The answer is B. An ammeter has very low resistance so that it can be placed. Ammeters are placed in series. It will not affect the circuit because of their low resistance. So it would be B. An ideal transformer has a primary to secondary turns ratio. This is getting mathematical. An alternating potential difference of 200 volts is applied to the primary coil and a resistance of 100. Yes, you can read the rest of that. Let me go ahead and set this up. So in class, you should learn that the number of turns on the primary coil over the number of turns on the secondary coil is equal to the voltage on the primary coil over the number of turns, the voltage in the secondary coil. And so first, let us find the voltage in the secondary coil, and then we can find the current because we already have the resistance right here. And so when you put in all the unknowns and flip things around, we get that Vs the 600 amperes, no, volts. This would be 1 and this would be 3, just FYI. So if we have the voltage being 600 and we have a resistance of this, V equal IR, am I correct? Yes, I am. So V equal IR. To get the current, you divide the voltage by the resistance, and that would be 3 amperes. '49. The following diagram labeled 1, 2, and 3 show the magnetic field lines plotted by a student. Which of the following are correct? Which of the following are correct? Let us look at all of them. So for the first one, look at those lines. Look at those lines for I. These are the lines I'm talking about. Do you see how all of them go towards the South Pole, exit the North Pole, some come around and go straight back to the South Pole and continue? That is what we were looking for in the last question and did not see it. So let's look at 2. 2 seems good too because we know that like poles repel, and this is what we would expect from the field lines. They would diverge. Opposite poles, however, we should expect to attract. So the North Pole field lines would be going out towards the South Pole field lines, which would be coming in. So our answer would have to be all of them. Well done, students who did this. 150. Which of the following voltage time graphs best represents AC voltage? AC voltage, alternating current. rotate. So the answer would be A. That circuit is rectified, but the power cannot be negative. The voltage will not be negative either, so it would fluctuate, it would alternate like this. One. Which of the following circuits will the lamp light up? So in this circuit we have a power source right here, power source in all of them. Let me use this as an example. We have a bulb, and we have this diode slash rectifier. There's a particular way that you have to arrange the circuit in order for current to flow. It's when you have a diode or a rectifier in it. So let me just draw right here this diode. Let's say it's a diode. Maybe work again. So we have the diode right here. The diode actually points in the direction of the conventional current flow. So current will be traveling from the positive side. So the positive side should be somewhere here to the negative side. So let's look for a circuit which has this. This one, the positive side would be A, the positive side would be right here. So that means positive side will be connected here. And that's incorrect. We want the negative side over here. So let's go to C. Nah, C has a lot going on for it. We see here at C where the positive side for this one is actually correct. However, if the current should reach right here, it would not flow because the negative side should be connected here. So let's leave this alone. We don't need to worry about that. Let's go down to D. D is using a capacitor. Where's the positive side? Now we don't see any positive side, no negative side, so that's out of the question too. Let's look at B. So B has a negative side connected here. You can see negative, and the positive side connected right here. So that means the current is flowing in the direction of the arrow of the diode, where the diode is pointing. So this would be the correct answer, B. And if you have any questions, just feel free to ask me. Which of the following options show the correct match of the component name and number? Without wasting any time on this, the answer is A. You can go and examine that. Get the video. 53. Given the following truth table with inputs A, B, and output C, which logic gate does it describe? So we see 0 and 0 gives us 1, right? 0, 1 gives us 1 again, and 1, 0 gives us 1 again, but 1, 1 gives us 0. So we see here where, let's look first at the first two inputs, which is 0 and 0. So false and false gives us true, it says, to be the result in C, and down in the last row, true and true gives us false. We know for the OR gate, right? For the OR gate, the second and third pair of inputs would be true for the OR gate, but also for the OR gate, the last one would be true, so it can't be an OR gate. Well, how about a NOR gate? So if it was a NOR gate, the middle inputs would not give us an output of 1. It would give us an output of 0, because we know for the OR, it would give us 1, but then for the NOR, it would give us 0. What about AND? The first one rules out an AND gate. Let's try the NAND. That must be the answer. So for a NAND gate, it's the opposite of an AND gate. So for an AND gate, 0, 0 would give us 0. But because it's the opposite of the output, we turn to 1. Also for the AND gate, you'd have 0 for the other two. Only the last one you'd have 1 for an AND gate. So this whole thing is a NAND gate, the opposite of an AND gate. And please go and revise your logic gates. If you have any questions on that also, you can ask. Before. In the scattering experiment conducted by Geiger and Marsden, some of the alpha particles were deflected. Explanation for this phenomenon is that the nuclear charge and mass are concentrated in a small volume, that's D. Which of the following cannot be deflected by a magnetic field? It would be gamma rays, C, because gamma rays is actually just raw energy, high frequency energy. Which of the following definitions of the term half-life of a radio which of the following are definitions of the term half-life of a radioactive nuclide? The answer to this would be I and II. So the time taken for an activity of any given sample to fall half its value, original value. The time taken for half the nuclei present in any given sample to decay. Yes. And let's see what 3 says. 3 says it is half the average number of disintegrations per second. No, brother, no. That's out. All of the options that have 3 in it must come out. 3 spoil the entire crop. So it is A. The nucleotide thorium 23490 contains. So thorium 234 contains 90 protons, as you can see by the atomic number, and 144 neutrons. Simple. So from second form, atomic mass number and atomic number, we should know those. D, 58. The answer looks like D. Yes. Yes. Which of the following statements describe the nature of the 3 types of emission from radioactive substances? Alpha radiation is a stream of helium nuclei. Yeah. Beta radiation is a stream of electrons. Yeah. Gamma radiation is an electromagnetic radiation of very high frequency. Oh, wow. We did say that. Yes. So it's all 3, which is D. Which of the following scientists discovered the relationship E equal mc squared? Let's say one of the easiest ones for that. Everybody should know that. Albert Einstein, C. Which of the following equations, and we're down to the last one. Which of the following equations for nuclear reactions is correct? Which one of these is correct? So we have, let's just get straight to the answer. Let's not waste any time. Let me annotate. So we have Radium here 226. And it decays and it forms this isotope. And let me see. It forms an alpha particle, which they say is a helium atom. So we should have mass number there, atomic mass number of 4, and then atomic number 2. When we add this to the isotope, I think it's radon. If we add this to it, we should get back the same atomic mass number as radium and the same atomic number as radium. And C actually gives us that. All the others, you can check them for yourself. They don't add up to the same atomic mass number and atomic number. So the sides of the equation are not what. Thank you so much for watching to the end if you did. Okay, next time. See you next time when we work another paper.